Good morning everyone. So today we are going to learn about NZ graph. N means what, Nana? Neutron number, and Z means what? Proton number. So neutron and proton. If you plot a graph between neutron number and proton number, what will happen? Okay, what it gives you. That is what today we are going to learn. Okay, if a graph plotted between the number of protons, okay, the number of protons on x-axis and the number of neutrons on y-axis. This is called NZ graph. A graph plotted between the number of protons on x-axis and number of neutrons on y-axis is called as NZ graph. So the NZ graph is like this. Okay. So in general, this NZ graph depends on the values of n and z. For example, the ratio of number of neutrons to the number of protons is equals to 1. Okay. That is the value. For example, neutron number is 20, proton number is 20. The ratio n by p or n by z, the ratio n by p is 1. Then it will follow the straight line. Okay, this is what the straight line graph. Okay, so in this NZ graph, the ratio of neutron and proton, the value of the ratio of the neutron and proton decides the stability of the nucleus. Okay, stability, how much stable it is. So now the ratio of the neutron and proton decides what, Nana? Stability. N by p ratio decides the stability of the nucleus. Stability of the nucleus. So now the nucleus stability, when this stability is maximum, the stability of the nucleus is maximum only when, here the stability of the nucleus is maximum only when the ratio between neutron and proton, n by p, is lies between 1 to 1.54, because if you take the ratio, that is neutron number is 50, for example, proton number is 60, if you divide the values of neutron and proton, and you will get the value in between 1 to 1.54, then only in between 1 to 1.54, then only the nucleus is very stable. Otherwise the nucleus stability is minimum. Okay, the ratio is less than 1, the ratio is n by p ratio is less than 1 or greater than 1.54. In this case, what will happen? Nucleus stability is minimum. Nucleus stability is minimum. Okay, look at the graph. So up to a less than 20, up to the atomic number less than 20, before 20 value of the proton and neutron, the graph is straight line motion. Okay, the NZ graph coincides, that is n is equals to z, then it coincides. For example, n is equals to 1, z is equals to 1, the point is here, n is equals to 2, z is equals to 2, n is equals to 3, z is equals to 3, like this. Up to 20, up to the atomic number less than 20, the value, the NZ graph coincides with NZ lines, that is up to 20 it is straight line. Then after that, what will happen? It depends upon the n by p ratio. For example, as mass number increases, as the number of the proton and number of the neutron increases, what will happen? The NZ graph deviates from the NZ line. This is what, Nana? N is equals to Z line. This is n is equals to Z line. Whenever the proton number and neutron number increases more than 20, in that case, what will happen? The graph deviates from the line. Okay, the graph is deviated from this line. As mass number keep on increasing, then the NZ graph also deviates from the NZ line. And which is also nearer to the neutron number. The line is nearer to the neutron number. First of all, the line is like this, and next the line is, as you keep on increasing the proton number and neutron number, the line is very near to the neutron number line. Okay, and the region, the shaded region indicates that this shaded region always gives you the stability, the nucleus stability. Okay, shaded region indicates that nucleus stability. Okay, this is what, Nana? Stability of the nucleus. The shaded region, other than this shaded region gives instability of the nucleus and stability of the nucleus. This is what about NZ graph, very important for the short answer question. Most of the times they are asking about the NZ graph. Nothing to be worried, it is very easy question. You have to take a proton number on x-axis and neutron number on the y-axis. Then simply you have to increase the mass number and take the graph. What will happen when you keep on increasing the mass number of the nucleus? What will happen? The stability of the nucleus, the line which is nearer to the neutron number, okay, the line which is not passing through the NZ line, which is away from the NZ line and which is nearer to the neutron number line. This is what about NZ graph. Thank you.